Hi math students, it's Mrs. Marcellus and my furry friend Furcott. Today we're going to learn about multiple representations of functions. Today's learning objective is students will solve algebraic functions by constructing and analyzing verbal, tabular, and graphical representations using real-world situations. Functions can be represented in multiple ways. They can be word problems, equations, tables, and graphs. Let's take a look at a couple real-world situations where we show all four representations of these functions. Are you ready to give it a try, Furcott? Then let's go to our first situation. A Canada lynx averages 4 kittens per litter when there is an abundance of snowshoe hares available for food. First, we will write an equation to find the number of kittens a Canada lynx will have in an unknown number of average-sized litters. Then we will make a function table to show the relationship between the number of kittens and the number of litters. First, let's write the equation. Since we are writing an equation, we know we're going to have an equal sign. We'll set the dependent variable, or the output, equal to something that happens to the independent variable, or input. In other words, we're going to put k equals something that happens to L. In every litter there are 4 kittens, so we'll multiply 4 times the number of litters to find the total number of kittens. Then we'll complete our function table. To complete the function table, I'm going to choose some numbers of litters and then multiply them by 4 to get the number of kittens. If there are 0 litters, that means that we'll have 0 kittens. In 1 litter, we'll have 4 kittens. 2 litters would result in 8 kittens, and 3 litters will result in 12 kittens. Now we'll proceed to the next part of example 1, where we will graph our function and analyze it. So far we have seen our function represented in word form, equation form, and in a table. Now we're going to graph the function and analyze the graph. Since the column on the left is the input column, those values will be the x-coordinates of our ordered pairs. The column on the right is the output column, or the y column, so those will be the y-coordinates. We'll start with 0, 0, then we'll graph 1, 4, 2, 8, and 3, 12. We can see that these dots fall in a line, and this is a linear function. In order to complete our graph, we will connect the dots. This particular function is going to start at 0, 0, so we're only going to have one arrow on our line. We would not have a negative number of litters. Our final step is to analyze the graph. Analyzing the graph means to look at the graph and express in words what it tells you. There are many different things that we can say about this graph. For example, the graph is linear because with each litter the number of kittens increases by 4. Again, this is just one example, and there are lots of things you can say about the graph. When you are asked to analyze the graph, we want to say more than "it forms a line" or "it goes up." Your explanation should have something to do with the data the graph represents. Let's move on to situation number 2. A lion can easily jump 5 meters in a single bound. A cheetah can easily jump 8 meters in a single bound. Write 2 equations, one for the lion and one for the cheetah, to find the number of meters that can be traveled in an unknown number of bounds. Then complete the function tables showing the relationship between the meters traveled and the number of bounds. First, we will write our equations. Let's start with the lion. The number of meters traveled depends on the number of bounds. Therefore, I'm going to start my equation with m equals. Since the lion travels 5 meters in a single bound, we're going to have m equals 5 times the number of bounds, or b. For the cheetah, we will have m equals 8 times the number of bounds, because the cheetah can travel up to 8 meters in a single bound. Next, we will complete our function tables. We need to put the number of bounds into the tables, then calculate the number of meters traveled. I'm going to use the same number of bounds for both tables so we can easily compare. I'm going to keep it simple and just use 1, 2, 3, 4 in both tables. To complete the lion's table, we'll multiply each input by 5. We will get outputs of 5, 10, 15, and 20 meters. In the cheetah's table, we will multiply each input by 8. This will give us 8, 16, 24, and 32 meters. Now that we've completed our tables, we will move on to the next step, where we will graph the functions and analyze the graph. In order to graph the functions, we will need to make ordered pairs from each table. We're going to graph both of them on the same graph so we can compare the functions more easily. We will graph the number of meters the lion travels in 1, 2, 3, and 4 bounds. In order to complete the graph of the lion, we will connect the dots. Our graph will have only one arrow on it because the lion is not going to take a negative number of bounds. Next, let's graph how far the cheetah travels in 1, 2, 3, and 4 bounds. Now that we have both of these functions graphed, we can analyze the graph. When we analyze the graph, there are lots of things we can say about it. Here are some examples. The cheetah travels further than the lion in the same number of bounds. The lion travels less than the cheetah in the same number of bounds. Both graphs are linear because the distance per bound is constant. The cheetah graph increases faster than the lion graph. Again, we don't want to just say both graphs go up or both graphs are line because that doesn't tell us much. When we analyze the graph, we need to talk about the data the graph represents. Hey Furkat, don't you think those were some pretty interesting facts about the lynx, the lion, and the cheetah? I had absolutely no idea that lynx babies were called kittens, just like cats babies are called kittens. And the lion and cheetah sure can leap a long distance. I know that cats can leap up to 6 times their length too, can't they? Well, math students, that does conclude our lesson on multiple representations of function, so we're signing off for now.